Welcome back to Chapter 1. Today we're going to be looking at Section 5, which we are going to be solving inequalities with one variable. We're going to start getting into this solving of inequalities thing where we have only been working with equations so far. The nice thing is that the difference is basically just that it's not an equal sign. It's a different kind of sign. And everything that you've done you're still going to do here. There's very little difference here than solving an equation. Our learning target, I can solve and graph inequalities. All right, so solving inequalities. If we have an inequality like this, 3x minus 7 is less than 5. To solve it, we're going to do the exact same steps that we do when we're solving an equation. First, we're going to have to get rid of that minus 7, so we're going to add 7 to both sides. So we have 3x is less than 12. Then we're going to divide by 3. X is less than 4. That's solving an inequality. Now there are some differences. We'll see that in a second. But actually one of the differences is your answer. We have x is less than 4. Then we also tend to graph this. Now we graph these on a number line. On a number line you should have 0 generally speaking. And then 4. You don't need a lot of other things. So we're going to have a dot there. The less than and greater thans give us an open dot. When we have a less than or equal to, or greater than or equal to, we get a closed dot. So being that it's less than 4, we're going to have an open dot on 4, and 0 is less than 4, so we go this direction. So we have the solving, and we have the graph. So there are some differences. If we look at this one, 5 minus 2x is less than or equal to 19. We're going to subtract 5 minus 5. So we have negative 2x is less than or equal to 19 minus 5 is 14. Now we're going to divide by negative 2, divide by negative 2, and so we get x. All right, now so when we multiply or divide by negative, and this is important, this is like the difference in solving equations versus inequalities. When we multiply or divide by a negative, the sign flips. So it was less than or equal to. Now it's greater than or equal to. It just switches direction. Technically, this happens with an equation too, with the equal sign. It flips, except when it flips, it's the exact same. So nobody cares. So x is greater than or equal to negative 7. We can graph it. We have 0, we have negative 7. It's an or equal to, so it's going to be a filled in dot on that value. And we want greater, so we want when it's to the right there. So that's the basics to solving inequalities. You do exactly what you would do for an equal sign, except if you multiply or divide by a negative, you have to flip that sign. So, oh, there it is. So I need to erase some of my stuff here. I went just a little bit too low. All right. And then I'm going to erase this graph too. If you miss seeing what that graph was, rewind a little bit. You can always go back and see it. All right. So this one on the left, same thing as if we're solving an equal sign. First thing we want to do is combine our like terms. We have some x's here. They're on the same side of the inequality, so we just combine them. Negative 3/8 x plus 2x. 2 is going to be 16/8 minus 3/8 is going to be 13/8 x minus 20 is greater than 6. Now we can add 20, So we have 13/8 x is greater than 26. And now to get rid of 13/8, we divide by 13/8, which is the same as multiplying by the reciprocal. So when we do that, we get x. It was a positive number, so it's still greater than. 26 over 13 is 2 times 8 is 16. So x is greater than 16. We can graph it. We have 0, we have 16. It's greater than, it's not nor equal to, so we have an open dot. And then greater than 16 is going to be that way. With this next one, first thing we need to do is distribute, just like if it was an equal sign. 14x minus 4 is greater than 9x plus 6. We need to move the x's to the same side. Now, remember, when I move my x's to the same side, I like to keep them positive. That means that when we divide, we won't have to flip the sign. It's one less thing to think about. So minus 9x minus 9x, 14x minus 9x is going to be 5x. Minus 4 is greater than 6. Plus 4 plus 4. 5x is greater than 6 plus 4 is 10. Divide by 5. X is greater than 2. So we have 0. We have 2. And we go that way. And it's an open dot because it's not an or equal to. So, you have a couple more on this page, and to try this topic, we have 5x plus 15 is less than or equal to negative 10. And we have 2x plus 5 is less than 3x plus 4. So what you need to do now is pause the video, make sure you have paper and pencil, work these two problems. When you're ready, come back to the video and we'll go over them. All right, so go ahead and pause the video now. All right, ready to have a look at these? If you didn't do them on your own, pause the video and do them on your own, then come back. So the top one, we need to get the x by itself, so we're going to subtract the 15. So we'll have 5x is less than or equal to negative 10 minus 15 is negative 25. Divide by 5. X is less than or equal to negative 5. Notice, even though that 25 was negative, when we divided, we're dividing by that positive 5. The one that goes to both sides of that inequality is positive, so we did not need to flip the sign on this. And then 0, negative 5, it's an or equal to, so we have filled in dot, and it's less. So we go to the less. Go to the left, which is to the lesser values. All right, next one, 2x plus 5 is less than 3x plus 4. To keep the x's positive, I'm going to subtract 2x. So we have 5 is less than x plus 4. Subtract 4. 1 is less than x, which we can switch this around if we want. We can make this x is greater than 1. When we flipped the order here, notice the sign flipped with us. We need to make sure it's still pointing at the same thing. It was pointing at the 1. So when we rewrite it, it still has to be pointing at the 1. We can't just move things to the other side without looking at the sign. And then our number line, we have 0 and 1. It's not an or equal to, so it's an open dot. And we want x is greater than 1. which is this direction, which you could have done it with 1 is less than x. We want all the values of x where 1 is less than that, so it would still be on that right side of 1. So it's just a little bit more difficult to think of than having the x on the left side of the inequality. Then one last thing, if we take a look at this one, we have 2x plus 8 is less than, then we can distribute 2x plus 12, right, because that went there and there. We can subtract the 2x, subtract the 2x, so we get 8 is less than 12. Well, our variables disappeared again. So what do we do? Same thing we do when it's an equal sign. What's left is either going to be true or it's going to be false. If it's true, it's an identity, and the answer would be all reals. The graph of that is literally the entire number line. If it's false, it's a contradiction. There's no solution. Remember, that's not x equals 0. There is no value of x that will make this thing work. And the answer to that's going to be an empty number line, just the empty set. So we need to look back. We have 8 is less than 12. Is that a true statement or a false statement? That's a true statement. So it's an identity. We have all reals. And if you had to graph it, it's just graphing the whole number line. Examples of false statements. 12 is less than 8. So, I mean, that's an obvious one. 12 is less than 12 is a false statement. 12 is less than or equal to 12 is true. That or equal to means that those two numbers could be the same and still have be a true statement. Without the or equal to, if the numbers are the same, it is a false statement because 12 is not less than 12. It is less than or equal to. Specifically, it is equal to. 12 is equal to 12. So when you're deciding if it's true or false, that where they're equal is the one really tricky point about it. That's where they could try to trap you. So hopefully you can see how solving inequalities is very similar to solving equations. And I will see you in class. But until then, keep working problems, keep asking questions, and as always, happy mathing.